building an AI image studio shouldn't be a hassle, because in this single video, we're going to build our own AI image studio that you can use for your SaaS project or even transform some images for yourself. In this app, we can upload an image and apply several AI transformation options. Let's dive into the demo. We'll upload an image and apply the background removal function. Within a few seconds, the background of our image is removed. Next, we test the background removal plus drop shadow tool. This removes the background and adds a subtle shadow, as we can see on the screen. Then we have the Smart Crop Square tool, which applies a smart crop to the image. We also have the Optimize and Resize tool, which optimizes the image and resizes it. Finally, we apply the Enhance Quality feature to improve our image's quality. We can also apply all the AI transformation tools to one image, as we're doing here, and it will generate the result as we instructed. This is going to be an exciting tutorial. If this sounds exciting, stay tuned and let's build this together. We're going to use the Imagekit documentation to build our AI transformations tool. It provides all the APIs we need to create our app, and we'll use Next.js. It's a powerful React framework for building server-rendered, static, or dynamic web applications. It offers features like server-side rendering, static site generation, API routes, and a file-based routing system, making it ideal for creating fast, scalable apps with minimal setup. Let's get right into building it. We're going to start by cloning the starter code for this project from my GitHub repository. Visit the GitHub repo in the description or type the URL you see on the screen. On the GitHub page, navigate to the repository tab. On this tab, we'll open the repository named Imagekit Starter Files. Click to open it. On the large green button labeled Code, click it. You'll see a drop-down with options for cloning this project. We're interested in the SSH option, so make sure it's active, then copy the URL. In your code editor, for mine, I'm using Cursor AI. I'll open the terminal by pressing Ctrl+tilde. Inside this terminal, I'll type git clone, paste the URL I just copied from GitHub, and append a period. This indicates we want to install the code in the current directory opened in the code editor. Let's wait a moment for it to finish cloning. Right after cloning, we'll see new files and folders appear in our code editor. We'll walk through them step by step, but for now, let's install the node modules for this project using yarn install. Use npm if that's what you've been using. We'll wait a moment for this to install. Now, let's run the command npm run dev to start the app. This will launch the project on port 3000. So let's open localhost port 3000 in a new browser tab to see what our starter project looks like. We'll return to this page soon, but let's start exploring the file and folder structure. Inside the app directory, in the layout file, this section imports global styles and Next.js components for metadata and viewport settings, along with font configurations. It sets up the foundational styling and structure for the entire application, ensuring consistent fonts and themes across all pages. We define the metadata for the app. The metadata export defines the site title as Imagekit Transform, with a dynamic template for page titles. It includes a description for SEO, explaining the app's purpose, uploading, transforming, and optimizing images using AI-powered tools. It also sets the favicon for the site. We also configure the viewport settings. The viewport export configures the theme color based on the user's system preferences, setting white for light mode and black for dark mode. This ensures the app's appearance adapts to the user's device settings. Then, we wrap everything inside the head component. Right after that, the body tag uses the CSS utility to combine CSS classes for minimum height, background styling, and font settings. It applies the font sans, font heading, and font display variables to ensure consistent typography across the app. We include the providers component. The providers component wraps the app's content with theme and UI providers, enabling dark light mode functionality and navigation. It ensures the app's children components pages are rendered with the correct theme and UI settings. Next, let's move to the providers file. Inside this providers file, this imports React, Next UI provider for UI components, and Next Themes provider for theme management. It also imports useRouter for navigation, setting up the foundation for the app's UI and theme functionality. We define the provider's props interface. The provider's props interface specifies that the provider's component accepts children React nodes and optional theme properties. This ensures type safety for the component's props. Then, we define the provider's function. The provider's function uses Next UI provider and Next Themes provider to wrap the app's children, enabling navigation with the router and applying theme settings, defaulting to dark mode. This ensures all components inherit the correct UI and theme behavior. Next, we'll explain the page.tsx file. Inside this file, this imports React hooks for state and callback management, React drop zone for file uploads, and UI components like buttons and cards from a custom UI library. It also imports icons from Lucid React for visual elements like upload and download buttons. We set up state for the uploaded image. Two state variables are defined: uploaded image to store the selected file and image preview to store a URL for displaying the uploaded image in the browser. These manage the image upload and preview functionality. We also define the onDrop function. The onDrop function, wrapped in useCallback, handles file uploads by taking the first accepted file, setting it as the uploaded image, and generating a preview URL. It logs the file name and is where Imagekit upload logic will be added later. Now, on localhost port 3000, when we upload an image, we can see the effect of the onDrop function. We'll talk more about how it works soon. The useDropZone hook configures the file upload area using the onDrop function to handle uploads. It accepts specific image formats, JPEG, PNG, etc., allows only one file, and sets a 10 megabyte size limit, ensuring controlled file uploads. We also define a reset function. The reset function clears the uploaded image and image preview states, resetting the UI to its initial state when the user wants to upload a new image. Let's skip the use demo image for now. Now, inside the return statement, this section renders a header with the title AI Image Studio and a subtitle styled using the font display and font sans fonts. It serves as the main heading for the app's homepage, setting the context for the AI-powered image transformation tool. In this section, if no image is uploaded, we see this screen on localhost, prompting us to upload an image. When we scroll down, we see the upload icon from Lucid React. Scrolling further, we see headers displaying upload an image and other text information on the platform. The next dev is responsible for displaying the buttons, the Choose File button and the Try Demo button. Next, we move to the section that displays if an image is present. To see this in action, let's upload an image and watch it come to life. We can see the title, Your Image, and the image element displaying the just uploaded image. The next section displays the AI transformation tools, which are empty for now, but we'll add them soon. Finally, we have the action buttons. There will be 2 or more, but for now, we have just one called the New Image button. Let's talk about Imagekit. Imagekit.io is a powerful cloud-based platform for real-time image and video optimization, transformation, and delivery. It provides a robust API and SDKs like the Next.js SDK to seamlessly integrate features such as resizing, cropping, background removal, drop shadows, upscaling, and other AI-powered transformations directly into your web or mobile applications. With Imagekit, you can store assets in your preferred cloud storage, manage them through a digital asset management (DAM) system, and deliver optimized media via a global CDN, ensuring fast load times and enhanced user experiences. It simplifies complex media workflows with URL-based transformations, making it developer-friendly and scalable for projects of any size. Now, on this very link, which has the documentation for Imagekit, it will be placed in the description as usual. On this demo page, we will learn how to remove and change backgrounds, add drop shadows, upscale images, and perform a couple of AI transformation tools. The documentation is very simple and easy to follow. At this section of the documentation page, it shows us each AI transformation function and the units consumed. For example, background removal uses 130 units, retouch uses 5 units, drop shadow uses 1 unit, and face crop is a free unit. We are going to learn how to use this platform so that you'll be able to do literally anything with Imagekit after this video. Now let's start setting up Imagekit in our project. To do that, use the Imagekit dashboard link in the description, sign up, and make sure we're on the same page as you can see on the screen. Let's search for npm Imagekit Next.js on Google and click on the npm link so we can install the package in our project. On this npm page, we'll copy the installation command and paste it into our terminal. If you get an error similar to what I have, kindly add the flag --legacy peer dips to your command and it should install successfully. Now, inside our app directory, we're going to create an API folder for Imagekit. Inside the API folder, create another folder called Imagekit upload and create a route.ts file. Inside this route file, we'll import getUpload auth params from the @imagekit/next/server package. Since this package lacks TypeScript type definitions, we add /@ts nocheck at the top of the file to suppress TypeScript errors, allowing the code to run without type checking issues. Next, we export the get function. Inside this function, we'll create a try-catch block. Inside the try-catch block, we'll destructure token, expire, and signature from the getUpload auth params function provided by the Imagekit package. The getUpload auth params function accepts an object with a private key and a public key. We'll set those up soon by creating a .env file. So we'll destructure token, expire, and signature. Let's create a .env file in our root directory. In this file, we'll add the Imagekit public key and private key. So let's move to the Imagekit dashboard and grab those. On the dashboard page, under the Developer Options tab, we can see the API keys and standard keys. I'll copy my public key and paste it into the .env file, then copy the private key and paste that as well. By the time this video goes live, this private key won't be in use anymore, so it's better if you create your own. Back in the root file, we'll add the private key and public key from the .env file. Good. Now we'll return response.json with token, expire, signature, and public key. Inside the catch block, we'll log the error using console.error and return a response.json object with an error message and a 500 status code. This setup ensures our API route securely generates authentication parameters for Imagekit uploads, handling errors gracefully if something goes wrong. Now, in your config folder, you'll find a file called Imagekit. Open it and let's work on it. Inside this file, we'll configure Imagekit and add all the transformation objects. In the Imagekit config, let's add the URL endpoint. Back in the Imagekit developer dashboard, let's copy the URL endpoint and paste it into the URL endpoint field. Along with the public key from process.env. Now, inside the transformation options, we're going to add a couple of transformations. Back on the Imagekit docs page, we'll use the AI transformation properties. We'll start with background removal, which is an object with two properties, standard and efficient. The standard option uses a high accuracy AI model for precise background removal, while efficient prioritizes speed with slightly less precision, ideal for quick processing. Then we'll add enhance, effects, and smart. Inside the demo image object, we add a transformations array of objects starting with background removal. This object has an ID of BG removal, a name of background removal, a description explaining it removes backgrounds instantly, with AI an icon set to eraser, a transformation parameter of eBegrimov, a cost of 10 units, and a category of background. These properties define the transformation's metadata and behavior for the UI and Imagekit API. Next is background removal plus drop shadow, followed by smart crop, face crop, and finally resize optimized. Now it's time to build the build transformation URL function. This function takes an image URL string and a transformations array, returning a URL with the applied transformations for Imagekit to process. We'll use an if statement to check if the image URL is empty or if the transformations array is empty. Then we build the transformation string by joining the transformations array with commas to create a single string for the Imagekit URL. Next, if the image URL includes demo, we split the URL into parts and find the index of demo. If demo isn't found, we return the original image URL. Otherwise, we extract the image path after demo and construct a transformed URL using the transformation str and the Imagekit demo endpoint, ensuring the transformations are applied correctly. Otherwise, we use a try-catch block to pass the image URL as a URL object, extract its path name, and remove the leading slash if present. We define the Imagekit account ID and strip it from the file path if it exists. Then, we join the transformations with colons to create a chained transformation string and build the final transformed URL using the Imagekit config URL endpoint and the file path, ensuring compatibility with custom Imagekit accounts. If an error occurs, we return the original image URL to prevent failures. Now back to the page.tsx file, we're going to start implementing the real functionality of the app. At the point where we have our state variables, let's add a couple more. As we type, we add a new state variable called is uploading, set to false initially. This tracks whether an image is being uploaded, so we can show a loading indicator. Next, we add another state variable called uploaded image URL. Set to an empty string. This will store the URL of the image after it's uploaded to Imagekit, and we specify it's a string for TypeScript. Now, inside the onDrop function, we are currently logging the name of the selected file. So on localhost port 3000, let's open our developer tools, upload an image, and check what we see. In the console, the selected image's name is displayed thanks to our console log. So let's keep building this onDrop function. We'll set is uploading to true and uploaded image URL to an empty string. This resets the image URL and signals that an upload is happening, allowing us to show dynamic information during the upload. Right after that, we'll add a try-catch block. We'll create a variable called authResponse to hold the result from uploading the image to the API/Imagekit upload /route endpoint, the one we set up earlier. If the authentication response isn't okay, we throw a new error. Then we extract token, expire, signature, and public key from the JSON response of authResponse. These values are crucial for authenticating with Imagekit before uploading the image, ensuring secure and authorized access to the Imagekit API. Next, we'll create a constant called uploadResponse and use the upload function from the Imagekit package we installed earlier. So let's import it. Inside the upload function, we add an object with these properties: file, which we get from the file object, file name taken from the file's name property, and token, expire, signature, and public key from the response of the upload auth endpoint. Next, we check if the upload response object has a URL property. If it does, we set uploaded image URL to the URL from upload response. We see a red wavy line, so let's add as any to the type for the uploaded image URL state to fix the TypeScript error. Now the red wavy line is gone. Then we console log the URL. If there's no URL, we throw a new error. In the catch block, we log the error, and in the finally block, we set is uploading to false. Looks like we made a mistake here. Let's scroll up and add a curly brace right after the first if statement in the try-catch block, then remove the extra curly brace. Now, on localhost port 3000, when we upload a new image and check the console, we see the URL of the image uploaded to Imagekit. Clicking it takes us to the image. Awesome. Let's continue building the app. We scroll to the section of the page with the image preview comment. we're going to add some conditions here. If its uploading is true, we show a message. The code we're adding creates a div with a light blue background in light mode and a darker blue in dark mode with a matching border. Inside, a paragraph displays a small text with an upload emoji and the message uploading to Imagekit. This gives users a visual cue during the upload process. Now, when we upload an image, we see the uploading to Imagekit message at the top of this section. If there's no uploaded image and its uploading is false, we show an error message. The code we're adding creates a div with a light red background in light mode and a darker red in dark mode with a matching border. Inside, a paragraph displays a small text with a cross emoji and the message upload failed. Transformations will use demo image. This informs users when an upload fails. This will show when the upload fails. Now, under the state variables, we add new states to display the AI transformation tools. We declare a state called selected transformations, initialized as an empty array of strings to track which AI tools the user selects. Then, we quickly add these icons: eraser, wand, zoom in, crop, and user from Lucide React. We also import transformation options from the Imagekit config file we created earlier. Now let's scroll to the transformation tools placeholder comment. Let's collapse the card content and create a new one for the AI transformation tools. Inside the card component, we'll loop through the transformation options. We create a card content with a class for vertical spacing of 3 and render the transformation options. Back in the Imagekit file, we made a mistake with the demo images variable. Let's rename it to transformation options. Now back to the page.tsx file. We scroll to the transformation options section. We'll remove the placeholder and add a function to get the main transformation options at the top. We create a constant called main transformations using transformation options from the Imagekit config. We apply a filter method to include only specific transformations: BG removal, BG remove shadow, smart crop, face crop, resize optimize, and enhance basic. This filters the list to show only the primary AI tools in our UI. Let's scroll back to the transformation tools section and loop through the options. Using main transformations.map with an option callback, we create the following. We need to create the icon map, so let's scroll to the top and add it. We create a constant called icon map, mapping tool names to Lucide React icons: eraser to eraser, scissors to eraser, shadow to undo, sparkles to sparkles, zoom in to zoom in, crop to crop, user to user, copy to sparkles, palette to undo, and edit to sparkles. This maps each transformation tool to its corresponding icon for display. Now, scroll back to the transformation tools section. In the return statement, we create a div with a key prop set to the options ID from main transformations. We add classes for padding, rounded corners, a border, and a pointer cursor with a transition effect. If the tool is selected, we apply a primary colored border and a light primary background. Otherwise, we use a default border that changes to a primary color on hover. This styles each transformation tool in the UI. Let's add an on-click event for toggling transformation tools, which we'll set up later. We define a div to display the tools, with classes for flex layout, centered items, and justified content. Inside this div, we create another div with classes for flex layout and horizontal spacing of 3. Then, we render the icon component with classes for a width and height of 5 and a primary color. We add a span to display the option's name, styled with a heading font and medium weight, showing the tool's name clearly. Finally, we add a condition to show a check mark if the tool is selected, rendering a check icon with a width and height of 4 in the primary color. This visually indicates which tools are active. Now, when we save and upload an image, we see the AI transformation tools we just added. The icon map displays icons aligned with the names of the AI tools. Super cool, right? Next, we'll create the toggle transformation function. Right before the reset function, we add the toggle transformation function. As we type, we define a function called toggle transformation that takes a transformation ID string. It updates selected transformations by checking if the ID is already included. If it is, we remove it by filtering it out. If not, we add it to the array. This toggles the selection of AI tools in the UI. Then, we check if processed image URL exists. Since we don't have it, let's create it quickly. We add a state for processed image URL and another for is image loading. Inside the if statement, we set processed image URL to an empty string and is image loading to false, respectively. Let's add the state for is image loading as well. Now, when we upload a new image and save the file, the AI tools aren't interactive because we haven't added toggle transformation to the on-click event. Let's do that now. We pass option.id as an argument to the toggle transformation function, since that's what it expects. Now, when we upload an image and select background removal, we see the selected tool highlighted with a check mark and the banner shows the image is uploaded. Awesome. Next, we focus on the action buttons. We scroll to the section with the action buttons and add a condition. If selected transformations has items, we show a div with centered text containing a button component. It triggers apply transformations on click, has a large size, extra padding, and is disabled during uploads. It includes a sparkles icon and text that says uploading if is uploading is true, or apply AI tools with the count of selected tools otherwise. This button lets users apply the selected transformations. Let's set up the apply transformations function. We scroll to the use demo image function and add apply transformations below it. As we type, we define apply transformations. If there's no uploaded image or no selected transformations, we exit early. We set is processing to true and processing progress to 0 and is image loading to false. We create a progress interval to simulate progress, updating processing progress by 15 every 400 milliseconds until it reaches 100, then stopping at 90. In a try block, we map selected transformations to the transformation parameters from transformation options, filtering out undefined values. We set base image URL to uploaded image URL if uploaded image exists. We call build transformation URL with base image URL and transformation params to get the transformed URL, log it, and set processed image URL to it. We set isImageLoading to true, processing progress to 100, and isProcessing to false. In the catch block, we log errors and reset isProcessing and processing progress. This applies the selected AI transformations and updates the UI. Now, before we test the app, let's scroll to the last part of the page under the New Image button and create a results section to show the image after transformation. Using the processed image URL state, if it's available, we create a div with a class for vertical spacing of 6 and add a section. The code we're adding creates a card with a green border that adjusts for dark mode. Inside, the card content has padding and centered text containing a circular div with a green background holding a checkmark icon to indicate success. Below, a heading says AI transformation complete in a bold, large font. This visually confirms the transformation is done. Then, we add a section. The code we're adding creates a card with a header containing a title, original, styled with a large heading font. The card content includes a div with a muted background, rounded corners, and a square aspect ratio, centering the original image using the image preview state. The image has classes to ensure it fits within the container and has rounded corners with an alt text of original for accessibility. Now, when we upload an image and click Apply AI Tools, we see the original image. Let's show the transformed image next. We add another section. The code we're adding creates a card header with a title, AI Transformed, styled with a large heading font and aligned with an icon. The card content includes a div with a transparent pattern, background, rounded corners, and a square aspect ratio, centering the transformed image from processed image URL. If its image loading is true, a loading overlay appears with a spinning loader 2 icon, a message saying processing transformation, and a note that it may take 10 to 60 seconds. The image has classes to fit the container with rounded corners and an alt text of transformed. On load, it sets its image loading to false. On error, it logs the error and also sets its image loading to false. This displays the transformed image with a loading state for user feedback. Now let's test the app. We upload an image and select background removal. We see the image of the cat with its background removed rendered beautifully. Let's host the app on Vercel. Open vercel.com and host our app. Before hosting, make sure you've pushed all the code to GitHub. Click the Add New button, select our project, and click the Import button next to it. In the deployment dialog, we add our environment variables. Copy the variables from the .env file in our code base and paste them into the environment variables section on Vercel. Now we can deploy it. I'm not skipping this part. I want you to experience what real hosting feels like and take you through the process. there's an error. Let's remove the navbar component entirely since we don't need it. Back in the code base, delete the navbar and push the code to GitHub again. Now the website is deployed. Let's upload the cat image and remove the background. We wait a moment and we see the background removed. Everything is working perfectly. Thanks for watching this far. Practice with the Imagekit docs and build your own project from what we've created. Practice makes perfect. Until then, see you in the next one.